Okay, cool. Enjoy the lesson.
Good evening, boys and girls. Welcome to another lesson on Technical Sciences, grade 12. We are dealing with a very important topic. Remember, organic chemistry, because it is part of paper 2 and it counts a lot of marks. And this week we've been dealing with the section on nomenclature, and we are concluding it basically today, the entire theory. But remember, in it we infuse questions in between. And tomorrow it's our question and answer session, and we are also expecting that you will be sending me a couple of questions that you want me to assist you with, or any comments or whatsoever to the email that I will give to you at the later stage for you to copy down. But we are continuing then with organic chemistry, and in particular nomenclature. So I hope you have your pens ready as well as your paper or your notebook so that you are able to take down notes. So in the overview of the lesson, we'll still be looking at nomenclature as per the examination guidelines, but briefly so. Then we will be finalizing nomenclature in terms of what you need to know. In particular, we will be looking at alcohols and also classification of alcohols and haloalkanes as well, and the classification of haloalkanes. And then we will be doing questions on nomenclature from previous examination papers so that you are able to see how these questions are asked. And lastly, I will be reminding you of the number of marks that this particular topic is going to be in terms of your preparatory examination as well as your final examination. Right, so this is as per your examination guidelines. What you need to know, remember, you need to be able to work with all these homologous series that I have identified there for you. Today we will be dealing with haloalkanes as well as alcohols. Remember, with alcohols, we actually have dealt with them. It's just that today we will be then classing them into primary, secondary, and tertiary alcohols, and we will do the same for our haloalkanes and classify them into primary, secondary, as well as tertiary alcohols. Then, you know, we must be able to give a couple of definitions there, and we must be able to draw functional groups and give names of functional groups. We must be able to work with isomers, give different types of isomers. And we've already done that, where we talked about the chain isomers, the positional isomers, as well as the functional isomers. Then be able to give Iupac names of different organic compounds, and as well as their formulae, either being structural formulae or molecular formulae. Now today, we are going to look at another homologous series, and this is haloalkanes. And remember, another name that is actually used for haloalkanes, that is what we refer to as, okay, that's not a good start to using our pen there. Get it again. Right. These are also called alkyl halides. So when you have your textbook and you see that they are referring to alkyl halides, there is no need for you to stress. Just know that they are talking about haloalkanes. The name or the homologous series, the name of the homologous series that we commonly use is haloalkanes. Now, when you look at this molecule is actually an alkane. Okay, actually there's a bond there and there's a bond there. Right, this molecule is actually a haloalkane, because when you look at it, you can see you are getting those single bonds between carbon and carbon atoms and the hydrogens. So this is sort of telling me that this is an alkane. But then I see there I have a Br. Now Br is a bromine atom. And this bromine atom belongs to a group of atoms that we call halogens. So this is actually an alkane that has a halogen bonded to it. And that halogen is Br. So it is actually an alkane that has a halogen in the form of Br bonded to it. As a result, this is not just an alkane, this is not just a halogen, we then call it a haloalkane. And be careful, it's not a halogen alkane. The name of the homologous series is then referred to as a haloalkane. Now, we must be able to give a name to this particular molecule. Now, as always, we start with the parent chain. And the parent chain, we can see it's actually 1, 2, 3 carbons long. So it is going to be a prop, right? It's going to be a prop. And because it's a haloalkane, then it's going to end with ANE. So this is then a propane. So the longest chain without breaking, it's a propane. And then we have a bromine there that we need to talk about, the functional group. And therefore this bromine, when we then include it onto the name, remember the parent chain is the one that we write at the end. And the functional group is bromine. So I'm going to put it in front, and that functional group, I won't say it is bromine. We shorten it and we say it is a bromo. After that, you need to tell them where the position of that bromine is, the functional group. And the position there, we can see it is bonded to carbon number 2. So I'm going to put a 2 there. Now, you can already see that this name cannot be correct because according to Iupac rules, I need to have a hyphen between a letter and a number. So I'm going to put a hyphen there. Are we together? So the name of this molecule is then called 2-bromopropane. And hence I've put it down there for you. I'm saying that this is 2-bromopropane. So you start with the parent chain. You then include the functional group, but you shorten it. You know it's bromine, but then you will call it bromo. And you also see that this bromine is attached to carbon 2, so you put a 2 there. Then you remember the other Iupac rule that says you must have a hyphen between a letter and a number. So the complete name for this molecule, or the Iupac name for this molecule, is then called 2-bromopropane. Then we also need to know the general formula of haloalkanes. And we must also know the functional group of haloalkanes. Now, let us start with the functional group. Remember now, if it is a haloalkane, the first aim is to say, I want to show you that a carbon is bonded to a halogen, and that halogen, we represent it using X. Why? Because it can be any halogen, and hence we normally say where X is equal to, and for your syllabus, it will either be bromine or it will either be chlorine. But for interest's sake, it could also have been fluorine, it could also have been iodine, because these are halogens. So X represents a halogen. So it's a carbon that is bonded to X, and X can be any of those. It's just that for your syllabus, we deal in particular with bromine and chlorine. And then you are halfway there, because you've shown us that I must look for a carbon that is bonded to a halogen. Then I need to then show that around each carbon, I must have 4 bonds. And there I have 4 bonds around a carbon. And for that, you are going to get 2 marks, because you've shown us the atom that we must look for when we want to see that this molecule belongs to haloalkanes. Now, let us work out the general formula of haloalkanes. Now, I told you that if it becomes a bit challenging for you to remember, then you can actually determine the general formula here. So you can check how many carbons you have, and you can see that I have 3 carbons. So you know it will start with the carbon, and N will represent the number of carbons. And then you will have an H. Are we together? And then you will have an X. Remember now, for the general formula, it could be any halogen. As a result, the halogen is represented using an X. Then we must check the hydrogens. And the hydrogens, if you check them and count them, you get 1, 2, 3, 4, 5, 6, 7. Now, can you see that the number of hydrogens is actually 2 times the number of carbons plus 1. So when I say it's 2 times the number of carbons plus 1, I'm basically saying it's 2 multiplied by 3, which gives me 6, plus 1, which is then 7. So the total number of hydrogens becomes 7. In other words, the number of hydrogens there can be determined by saying it's twice the number of carbons, you know, N represents carbons, plus 1 hydrogen, and X represents your halogen. And you can check it. How many carbons do we have? C, where I see and I put the number of carbons, it's 3. H, 2. Remember, N represents the number of carbons. Then that will be a 3 plus 1 X. And this will give me, and in fact, for now, in this molecule, we actually know what X is. So I can somehow just write it there. And my X is Br. Then if you work it out, it will give you the molecular formula, which is C3H, 2 times 3 is 6 plus 1, it's 7. So it will give me C3H7Br. Now, is it correct? The number of carbons is 1, 2, 3? Yes. The number of hydrogens is 1, 2, 3, 4, 5, 6, 7? Yes. The number of bromine atoms is 1, it's 1. Then the molecular formula is correct, which then means the general formula is also correct. So a general formula, my dear learners, you can actually work it out even if you have forgotten it altogether. But I know that you never forget. Okay. Then let us talk about isomers. Now, if we want to talk about isomers, then It means we need to check for molecules that have the same molecular formula but different structural formulae or structural formula in singular terms. So there I have 2-bromopentane. So let me draw isomers of 2-bromopentane. Remember, in itself, it is an isomer. Now, how do I draw 2-bromopentane? Firstly, I need to analyze the name. So this part, which is the pentane part, represents what? The parent chain. So this represents the parent chain. So the parent chain, most definitely, it has 5 carbons because it is a pent. So I'm going to draw a molecule with 5 carbons. It's 1, it's 2. Okay, that's too large. So that will be 1, that will be 2, that will be 3, that will be the 4th carbon, and that will be the 5th carbon. And the name ends with ANE. In other words, I have single bonds between carbon and carbon atoms. And the bromo means I have a bromine there as my functional group. And the 2 means the bromine is on carbon number 2. So if I number from left to right, I will say this is carbon 1, that is carbon 2, that is carbon 3, that is carbon 4, that is carbon 5. Now, my dear learners, this is for teaching purposes. Remember, we don't want you to show us how you've actually numbered the carbons. Then I know on carbon number 2, I need to have a BR. Now, remember your bromine, it's a capital letter B with a small letter R. And the only thing left is to make sure that around each around each carbon, I have 4 bonds. So there I'll have 2, I'll add another 2 there, and there it's 1, so I'll add 3. And then I put my hydrogens. There we go. Okay, that's not a nice hydrogen, we'll fix it. Okay. There we go. Right, so this one, it's 2-bromo. There we go. Now let us draw an isomer of 2-bromopentane. So what I can do is I need to make sure that the molecular formula stays the same, but the structural formula doesn't stay the same. So I can go and actually say, okay, I still need to make sure that the molecular formula is the same. Remember this one, the number of carbons is 5. The number of hydrogens, it's 11. The number of Br, it's 1. There we go. Then I need to draw another molecule which will also be 5 carbons, 11 hydrogens, and 1 bromine. So this will then be 1, 2, 3. Okay, trying my best here. Right. Okay. Must actually be very slow if I want it to look nice. Okay. Hope you're not laughing at my handwriting. 4, 5. Then What I can do is to make the structure different. I can take this bromine and put it on carbon number 1. So I'll bring the Br there, and then I'll bring the H there. Then I just complete my molecule. All right. There we go. 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 Yes. Just have to put my hydrogens. Okay. Can see what I'm doing. Doesn't have to look too nice. Right? Then if you look at this molecule, how many carbons? 1, 2, 3, 4, 5. There we go. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many bromines? 1. So it's C5H11Br. What will be the name of this one? The longest chain without breaking it? 1, 2, 3, 4, 5. So it is a pent. And single bond between carbon and carbon atoms, right, with hydrogens. So it is a haloalkane because there's a Br, so the name will end with ANE. Okay, good. Then I have a bromine, so it will be a bromo. And this bromine is on carbon number 1. Then I put a hyphen. So this one is 1 bromo pentane. Then let us draw another one, which is then 1, 2, 3, 4, 5. Then this one, I put it to carbon 1. This one, I can take it to carbon 3. And this one is carbon 3, whether you number from left to right or from right to left. Then I'm just left with putting my hydrogens. Here we go. You can check this one as well. I'm definitely sure that this is also a C5H11Br. Okay, let's fix that one quickly. It's a C5H11Br. So what can you see? This one, it's a pentane as well because it's 5 carbons. The name ends with ANE. And then I also have a bromo. So I'll bring it to the front. That is a bromo. And I can see that this bromine is on carbon 3. So this one will be 3 bromo pentane. Now you can see the bromo there is on carbon 2, the bromo there is on carbon 1, the bromo there is on carbon 3. The molecular formulae are the same. So these are organic molecules with the same molecular formulae, but they have different structural formulae. Why? Because of different position of the functional group. The Br there is on carbon 2, there it's on carbon 1, and there it's on carbon 3. So if I asked you what type of structural isomers are they, you would have said to me, Meneer, these ones are positional isomers. Why are they positional isomers? Because these are organic molecules with the same molecular formula, but different positions of the functional group. Then if I ask you, how many isomers does this molecule have? You are going to say to me, Meneer, it has 3 isomers altogether. 1, 2, 3, they are isomers of each other. And we say they are positional isomers. Why? Because when we define positional isomers, remember what we said? We say they are organic molecules with the same molecular formula, but different positions of what? In this case, it is the functional groups. Are we together? Right. So I'm sure you are now extremely good with working with isomers. Now, let us talk about classification of haloalkanes. Now, we have haloalkanes like this one. Let me do this. 1, 2. Just a simple one. Let me draw there a BR. Right. Now, this one, if I asked you for the name, you would have just said to me, Menier, this is 1-bromo ethane altogether, or simply bromo ethane, because the BR, whether it's this side or that side, it's just going to be on carbon number 1. Now, when we look at this BR, when we look at this haloalkane, why is it a haloalkane? Firstly, because it is an alkane with a halogen bonded to it. Then we classify this haloalkane as a primary. Okay, my handwriting today, it's not so nice. Right. This one, we call it a primary. It's a primary haloalkane. And why are we saying it's a primary haloalkane? Because and we'll ask you for this, my dear learners, the carbon bonded, because the carbon bonded to, and I hope you are taking this down, to a halogen is to only one carbon right. So to classify a haloalkane as a primary haloalkane, you first go and look. Okay, I'm trying to get something. Yes. Right. You go and look for the carbon that is bonded to the halogen. Can you see? This is the carbon that is bonded to this halogen. So the carbon that is bonded to the halogen, can you see that it is only bonded to one carbon atom? So this carbon that is bonded to the halogen is bonded to only one carbon atom. And hence we say it is a primary haloalkane. Now, what does this mean? It means that when I'm talking about a secondary haloalkane, then it means the carbon that is bonded to the halogen must be bonded to two other carbon atoms. Right. Let's do a secondary haloalkane. Right. Right, back to my red pen. There we go. So now, let me say I ask you to do for me a secondary haloalkane. Now, for the secondary haloalkane, we will do as per as per the its requirements. And that is then to say, okay, then and what I would actually want to do here is to do something like this. For example, a BR. So one learner is saying to me, Minier, by just looking at this, I can definitely see that it is a haloalkane because I see single bonds between carbon and carbon atoms and hydrogen, and I see a halogen bonded to this. Now, why is this a secondary haloalkane? Remember what I said to you? All that you are really going to do is you will look at the carbon that is bonded to the halogen, which is this carbon. And this carbon is bonded to two other carbon atoms. So what will be your reason for saying this is a secondary haloalkane? You'd have said the carbon bonded to a halogen is bonded to two other carbon atoms. You can see that the carbon bonded to the halogen is bonded to this carbon and it's bonded to that carbon. So that will be a secondary haloalkane. Then let us do a tertiary haloalkane. So for a tertiary haloalkane, right? Tertiary. For a tertiary haloalkane, then you would have said, okay, it means the carbon that is carrying the halogen must be bonded to three carbon atoms. So let's say I want this carbon here to be bonded to a halogen. What does this mean now? It means this carbon must be bonded to three other carbon atoms. So what I see is this one is bonded to one, it is bonded to the second one. It means I need to have it bonding to another carbon atom. And when you look at this, we can definitely see that this is a good example of a tertiary alcohol, rather a tertiary haloalkane. Then if I ask you why are you saying it's tertiary, because you are going to say to me, say, this carbon that is bonded to the halogen is bonded to 1, 2, 3 other carbon atoms. So the carbon bonded to a halogen atom is bonded to 3 other carbon atoms. So that is the classes of haloalkanes. Then in the classification of alcohols, my dear learners, I just wanted to give you that as a task to say, go and do classes of alcohols in terms of primary alcohols, secondary alcohols, as well as tertiary alcohols altogether. And for you to be able to just do those, then you need to then be able to remember that the carbon now that will be carrying the OH group, if it's primary, it will be bonded to 1 carbon atom. If it is a secondary alcohol, the carbon carrying the OH group will be bonded to 2 other carbon atoms. The carbon carrying, if it is tertiary alcohol, the carbon carrying the OH group will be bonded to 3 other carbon atoms. The only thing that I wanted to show you with this is to say, remember now, when it is an alcohol, what you must actually have is your functional group as a hydroxyl group. Now I want us to move to questions. Right. So basically with that, my dear learners, we have completed the section on nomenclature. So We are wrapping up our lesson with questions, and tomorrow it's also going to be a 2-hour question and answer session, and we'll be dealing with lots and lots of interesting examination questions. Now it says, consider the organic compounds represented below. Rather, consider the organic compound represented below. So there is our organic compound. So if I examine this organic compound, before I even go to the question, I can see that this organic compound is an alkene, right? I can see that it's an alkene. Number 2, I can see that it is definitely a hydrocarbon. Why is it a hydrocarbon? Because this molecule contains only carbon and hydrogen atoms. Why is it an alkene? Because it has a double bond between carbon and carbon atoms. And I know that if I have a double bond between carbon and carbon atoms, then this molecule, we say it is unsaturated altogether. Furthermore, I can see that the longest chain without breaking is 4 carbons, and there I have a branch altogether. So there's a lot that I can learn from this molecule. Now they ask us, the compound is, they give us the options. Now let us check which options are correct and which ones are incorrect. And there's only one option actually that is correct. So let us do elimination. They say the compound is saturated. Our answer is no, it's not saturated. So this is not true. And they say it is branched. Yes, it is branched, but the fact is that it is not saturated. So this is incorrect. Then they tell us the compound is unsaturated. We say yes, it has a double bond. That is 100% correct. And it is branched, and we say yes, there is a branch there altogether. So this option is definitely the correct option. Saturated, we said no, it is not saturated. Straight chained, no, it is not straight chained. There is a branch. So you see, these questions are also a learning curve. Is it unsaturated? We say yes, it is unsaturated. Is it straight chained? We say no, it is not straight chained. So this is incorrect. This is incorrect. So the only option that is correct is then option B. Then they ask us, a structural isomer of butane is, then they give us all those options. Remember now, if we deal with isomers, isomers or structural isomers are organic molecules with the same molecular formula but different structural formulae. So let us actually learn this. Butane looks like this. But means 4 carbons. So it's 1, it's 2, it's 3, it's 4. Then I just put my hydrogens. So there's my hydrogens, there's my hydrogens, there's my hydrogens. There we go. So if you look at butane, right? How many carbons? It's 4. So it has 4 carbons. So it's a C4. How many hydrogens? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's C4H10. Now, if I want to do this one, it's butane. Right, I just want to show you how do we actually get to the correct answer. So you can't just choose. There is some work that you need to do. So there I am trying to draw butane. Then, if I want to make an isomer, remember now everything is carbon and hydrogen, so I'd rather shorten the chain. And this part that I shorten, this part that I'm shortening, then I put it as a branch, meaning now for the isomer, I then make my chain to be 3 carbons long. And if my chain is 3 carbons long, then I take the other carbon, which is the fourth carbon, to be a branch. Then my hydrogens, we can see it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So this is definitely an isomer of butane. It's C4H10. But they didn't ask us to draw the structural formula of butane. They wanted its name amongst these. So the longest chain without breaking here, it's 1, 2, 3 carbons. So it's a prop. And it's an alkane, so the name ends with A-N-E. So if I say 1, 2, 3, it means this one is not part of the longest chain. And this, I know it's a methyl. We know this by now. It is a methyl. And I can see this methyl is on carbon number 2. So I'll put a 2 there. And remember, between a letter and a number, I need to put a hyphen. So this is then 2-methyl propane. And the correct answer then is C. And remember, we are going to get how many marks? 2 marks. Very nice question. Right? Then they ask us, which one of the following compounds represents a ketone? Now we know a ketone has that functional group that we call a carbonyl group. And that carbonyl group, we know we get it between 2 other carbon atoms. So it's a C double bond O, which we must get between 2 other carbon atoms. So let us go and look for it. So we analyze this molecule, and there I see a C double bond O, and this C double bond O is between 2 other carbon atoms. And I definitely know that option A is correct, and I'm going to get 2 marks. Let's check why this one is wrong. This one is wrong because a ketone actually must have that C double bond O between 2 other carbon atoms. And you see there's an additional O. This is actually an ester. So this one is incorrect. This one, it's a carboxylic acid. Can you see there? It has a carboxyl group on the first carbon, C double bond O with an OH. So it's not a ketone. This one, it has an OH, that is a hydroxyl group, so it's an alcohol, so this is incorrect. So the correct answer there is A. Then consider the compound with the molecular formula C4H10. How many structural isomers does this compound have? And I want to make it simple for you. This is actually what we are talking about. Can you see? C4H10. So I was able to draw this butane. I was able to draw 2-methyl propane, and we said these are isomers. Now, you can't shorten this chain any longer. You can't make the chain to be 2 carbons long, because if I wanted to shorten it, for example, take it and bring it there, it would then be 1, 2, 3, 4. If I took this one and I brought it there, the longest chain without breaking will be 3. So it means butane only has 2 isomers. It has this isomer and it has that isomer. So our answer there is going to be B with a 2 altogether, and the rest are incorrect. Then the next question they ask us, which one of the following compounds cannot be an alkene? Now we want to know which one cannot be an alkene. Remember now, you could actually try and draw this and see which one is definitely not an alkene. But the best thing to do is remember the general formula of alkenes. It's CnH2n. Now, the question is, which one of the following compounds cannot be? So we want the one that is not an alkene. So the general formula is CnH2n. So you can check. If you have 2 carbons, it will be C2H2 into 2, so it will be C2H4. So this one is definitely an alkene. Then let us check this one. So if I substitute 3 there, where I see N, and I substitute 3 there where I see N, it will be C3H2 times 3 is 6, so this will be C3H6. So this is definitely an alkene. Let us check C. If I put a 3 there on N, I put a 3 there on N, it gives me C3H6. It doesn't give me C3H8. So this cannot be an alkene. So this is the correct answer because we want the one that cannot be an alkene. Can this one be an alkene? Yes, we can check it. If I put number of carbons, there's 4, and I put N there for 4 next to N, it will be C4H2 times 4 is 8, so it's C4H8. So all of these are alkenes, but this one is definitely not an alkene. Then the next question says, which one of the compounds represented below is an unsaturated hydrocarbon? Number 1, it must be unsaturated. Number 2, it must be a hydrocarbon. Let us check if all these molecules are hydrocarbons. Now this one is completely out. It's not a hydrocarbon because it has an oxygen. So hydrocarbons are organic molecules that contain carbon and hydrogen atoms only. Then, if I look at this molecule, is it a hydrocarbon? Yes, only hydrogen and carbon atoms only, so I'm happy with that part. Is it unsaturated? Yes, it is unsaturated because it has a double bond between carbon and carbon atoms. So this definitely is the correct answer. Is this one correct? No, it's not correct. Is it a hydrocarbon? Yes, it is a hydrocarbon because it's only carbon and hydrogen atoms, but is it unsaturated? And our answer is no, it's not unsaturated. It is saturated because it's single bond between carbon and carbon atoms. So that one is out. This one, firstly, it's not a hydrocarbon because there are other atoms other than carbon and hydrogen, so it's definitely not a hydrocarbon, so that completely eliminates it altogether. So these are the type of questions that you should expect as multiple choice questions in the section on nomenclature. Then in your, okay, furthermore, we are asked to consider the 2 organic compounds represented by 1 and 2 as shown below. Then they ask us, which one of the following correctly represents the homologous series to which each belongs, right? So molecule 1, they are giving us the class of homologous series. Molecule 2, they are also giving us the class of homologous series. Number 1, let us check this one. This one, we can definitely see that it's a ketone. Why? Because I have that carbonyl group bonded to 2 other carbon atoms. So when I see molecule 1, I know it's a ketone. Then when I see molecule 2, I see I have a C double bond O on the first carbon. In other words, molecule 2 is definitely an aldehyde. And it's actually an aldehyde with 1 carbon. So this is methanol. So there I have a ketone, there I have an aldehyde. So the correct combination is ketone, aldehyde. So the correct answer there is C. And I'm going to get 2 marks. Definitely 2, it's not an alcohol, there's no OH. It's not an alcohol, there's no OH. It's not a ketone, the C double bond O is not between 2 other carbon atoms. 1, it's definitely not an aldehyde. 1, yes, it is a ketone, but you see the combination with that is wrong. 1 is definitely not an aldehyde. So the correct answer there is option C. Now, let us just do one structured question. Then, the chemical properties of organic compounds are determined by their functional groups. That's true. You will understand that when you do organic reactions. The letters A to F, It's actually A to E. In the table below, represent 6 organic compounds. We actually have 5 there. Then I see all the organic compounds there. I just want us to go to the questions. We are required to write down the letter that represents the following. Now, there you've been given an instruction. You need to write down the letter all together that represents the following. 5.1.1, it must represent an alkene. So which molecule is an alkene there? Let us start with A. Okay, alkene. This one is definitely an alkene. Why? Because there's a double bond between carbon and carbon atoms, and it is a hydrocarbon. So the answer for 5.1.1 is definitely E altogether. And definitely with the others, it's not there. Then we must write a letter that represents an aldehyde. Remember, aldehyde, their names end with al. So when I say methanol, you definitely know that I'm talking about an aldehyde. So our answer there is D. Just some correction there. You see, I'm saying the answer is A, but then I write E. Right. Just to fix it there for you, we definitely said A is the alkene, and then D is the aldehyde. Then we are required to write down the Iupac name of the following: compound B. So if I want the Iupac name of compound B, I look for the longest chain without breaking. The longest chain without breaking is 1, 2, 3. So this is definitely going to be a prop. Now this molecule is a haloalkane. Why? Because there's a halogen there. So it means its name will end with ANE. Then we check, okay, I have my functional group there as bromine. So I'm going to write it as Bromo, right? And I just want to put it there somewhere on the side. It's Bromo. And I can see that this Bromo is on carbon number 1. So in other words, this is a 1 Bromo. Then I can see that this one, I did not count it in the parent chain. So it is a substituent, and it's a substituent with 1 carbon. So it is a methyl. You will remember that. And I can see that my methyl is on carbon number 2. So I'll say 2 and I'll put a hyphen. Then to give the full name, because it's a long name, remember I started this side with the parent chain, which was propane. Propane. So I have the functional group there, which is 1 bromo. I have my substituent, which is 2 methyl. So how am I going to put this in front? Remember, I have to use alphabetical order. So it's 1 bromo, so it's a B, and then it's an M. So the B comes before the M. So it means I will start with that one. So this will then be 1 bromo, right? And then I want to put a 2 methyl. So remember now there must be a hyphen between a letter and a number. So I put hyphen 2, hyphen again, I'll put my methyl. So the full name here is 1 bromo, 2 methyl propane. My propane is quite far. So let me just put it there. Right, so this is 1 bromo, 2-methyl propane, right? And for that, I'm definitely going to get 2 marks. Then we must give the Iupac name of compound C. Then I look for the longest chain without breaking. It's 1, 2, 3, 4, 5, rather 1, 2, 3, 4, 5, 6, or 1, 2, 3, no, 1, 2, 3, 4, 5, 6, yes, 1, 2, 3, 4, no, 1, 2, 3, 4, 5, no. So either way that you count, it gives you 6. Now, if I want to number this, I check that if I say this is the parent chain, this one, then this will be a substituent. This one will also be a substituent. If I number from left to right, then one substituent, this substituent will be on carbon 3, that substituent will be on carbon 5. But if I number from right to left, then this substituent will be on carbon 2, that substituent will be on carbon 4. So now, numbering from right to left actually goes with Iupac rules, because then the function, rather the substituent will be on the lowest numbered carbon. So I will say this is a 1, this is a 2, this is a 3, a 4, a 5, a 6, right? For the sake of space, I'm just going to erase there. Then we are going to say, okay, okay, I'll somehow just write it there for the interest of space. So the longest chain without breaking is 6 carbons, so it's a hex. Then everything is a single bond, so this is definitely an alkane, so this is a hexane. Then I see on carbon 2 I have a methyl, so it's a 2-methyl. Then on carbon 4 I have a methyl, so it's a 4-methyl. Now, what can you see now? Remember, these ones have to come in front. But because I have 2 of the same substituents, because they are both methyl, then remember the Iupac rule says you must then say that this is a dimethyl. Why are you saying this is a dimethyl? Because you have 2 of the same substituents, so we then say it's a di, because di means 2. Then you need to give the positions. So one is on carbon 2 and the other one is on carbon 4. Then why am I saying 2 and 4? Because one substituent is on carbon 2, another substituent is on carbon 2. And remember, according to Iupac rules, you must have a comma between a number and a number. And we are still not done. According to Iupac rules, I must have a hyphen between a letter and a number. Right, so the full name of compound C is 2,4 dimethyl hexane, and that is 2 marks. Then we are asked to write down the structural formula of compound D. So compound D is an aldehyde. How did you see that it's an aldehyde? Because the name ends with Al, right? It ends with Al. And we can see again then that to draw this one, we look at the entire name. So it's a meth. In other words, it has 1 carbon. Okay, I'll just somehow do it there. It has 1 carbon. And we know, how do we see an aldehyde? It must have a formal group. So which is a C double bond O with an H on the first carbon. Then I check, each carbon must have 4 bonds. So it's 1, 2, 3. Then to make it 4 bonds, then it will be another H, and this will then be 2 marks. Then we are required to write down the Iupac name of the carboxylic acid shown in the table. Now we must first go and identify the carboxylic acid, and we can definitely see that E is a carboxylic acid because this is a carboxyl group. C double bond O with an OH, and the carboxyl group is actually on the first carbon, right? So I can see that this is a carboxylic acid with 2 carbons. In other words, it will start with F. And remember, it ends with oic acid, but I have to put my AN. Remember, I taught you that. And because it's a carboxylic acid, then the name ends with oic acid. So the full name of this molecule is then ethanoic acid. And remember, you can't say it's ethan 1-oic acid. You can't put the position of the functional group because in itself, being on position 1, being on the first carbon, it's why we call it a carboxyl group. So this is more or less what you should be expecting to get when you get your paper 2 under the section of nomenclature. Then to conclude this topic, remember nomenclature itself is plus minus 29 marks. So in tomorrow's session, we will be doing questions on nomenclature, and it will definitely concretize our lesson for today and the lesson and everything that we learned for the duration of the week. So I hope you had fun with me because I definitely did. Remember again, send me questions to stemdigitalschool@africateengeeks.co.za. Thank you so much for tuning in and enjoy the rest of the evening. Goodbye.